Howdy tubers, welcome back to the Zach Live. This video is going to be part of the playlist in Series Oilfield 101. Today we're talking about injection wells. I kind of led into the idea that we were going to talk about the injection well on the new lease. It was quite a mess, but I decided I'm going to do a video just about injection wells, and then I'm going to tell the story in a video next week or very shortly about the new lease. I've scratched in my head about how to make this make sense, how to visualize it, and I think that I'm probably going to cut back and forth. And we'll go up to the office when I'm done here and draw some pictures, see if I can give some kind of schematics of what's going on. Let's step out there and take a look at it. Okay, so right here is a standard normal injection well. The only thing that's kind of unusual about this is it is set up as a relatively low pressure well. I'm injecting water through 2-inch poly. You can see it's currently got 105 psi, something like that on it. This well is permitted to 700 and something, 760 or 740 psi. I don't remember exactly. That is the maximum authorized pressure that we can have on this. We got several things to look at here. This is the 2-inch tubing. This tubing goes all the way to the just above the formation. It has got a packer on the end of this tubing, and this is, we talked about packers last week. The packer is what seals between this tubing and this piece of pipe. This piece of pipe here is 4.5. It's got a flange here on it, like they have nippled this up or something. I'm not really sure exactly what's going on there. But anyway, this is the 4.5, the casing, and then this piece of pipe here is the surface pipe. And this surface pipe goes down to just under 100 feet. We have to set 100 feet here, and generally they're set at like 102 or 105 feet or something to that effect. We've got a couple of annuluses. You're going to hear me use that word. The annulus is the annular space between two pieces of pipe. So between here and here is an annulus. Between the 4.5 and the 2-inch, 2 3/8 is an annulus. And we're measuring the annulus pressure on two different annuluses here. This is between the surface casing, the surface pipe, surface casing, same thing, and the casing or the long string. Both those phrases mean the same thing. And then we are measuring the annulus here between, the gauge looks like it's about dead, between the tubing and the casing, or the tubing and the long string. So when this well was drilled, when an injection well is drilled, or this well was drilled as a producer, the first thing that happens is the rig comes in here and sets up right here, and it digs a hole just under the depth of the usable groundwater, which here's 100 feet. So it digs down to, say, 102 or 103 feet. At that point, there's nothing here. There's nothing. It's just a hole. They'll run 102 or 3 or whatever feet of this pipe here. I believe this is 7-inch, but it might be 8 5/8. It's hard to guess. Anyway, they'll run 103 feet of this 7-inch pipe. And at that point, like I say, there's no casing or anything in it, no long string. They'll pump cement down this, down the surface pipe. It goes out the bottom of the surface pipe and up the outside, and it'll actually come up around the outside here. Anyway, then they let it set up for a few hours, and that cements the surface casing in. Now, if this was a place that we had to worry about blowouts, this piece of pipe is where the BOP would attach to. Now in this area, that's just simply not really a concern. We don't run BOPs. It's just not necessary. There's just not enough pressure down there to bring anything to surface. Anyway, so they'll take this another bit now, a 6 3/4 whatever, that goes in a 7-inch, and they'll actually drill all the way down through here, through the center of the surface pipe. They'll drill all the way to TD. So in the oil business, when you say TD, that literally means total depth. But you'll hear that word and that phrase used a lot where its literal meaning doesn't really fit right Englishly, if you would. Some people can use it as a verb. It can be used sort of as a verb. Somebody says, well, we TD'd that well. Well, that means that they, got to its total depth, or they finished it, or they finished drilling it. Or if you're cleaning out a well, we TD'd it. That means you got all the way back to bottom. Anyway, that's a phrase that you might hear me use, we TD'd it. Well, that has a little bit more meaning than just than its literal definition. So at this point, after you've got a 1,700 feet deep, 6 3/4 hole in the ground, you'll run your long string. This 4.5 will be ran all the way to as deep as you need it to go. And that's not necessarily always to the very bottom. It's not a real uncommon situation where you'll have someone that digs a deeper well, say they go to 3,800 feet, and when they get to 3,800 feet, the formation that they're chasing is not there. But they look back up the hole, and there is, say for instance, a 600-foot zone, and that 600-foot zone looks like it might make a well. It's not uncommon to dig a hole that's, say, 4,000 feet deep and only put 600 foot of casing in it if there's nothing that looks like it's there under 600 feet. Now, to do that, you've got to set several cement plugs in the well, and there's a few more hoops you jump through. But anyway, you effectively, after your hole is dug, you'll run your 4.5 down there to as deep as you need it to go. This well had a TD of about 1,700 feet. The formation is about 1,600 feet, and they set about 1,650 foot of 4.5. All those numbers are rounded, but that's a really good representation of it. Is like 1,600, 1,648, and 1,710 or something. It's a very good representation of what is actually in the ground here. Anyway, at that point, you'll pump cement down the inside of the 4.5, and you will calculate how much cement you need. You don't necessarily bring this cement all the way to surface. You've got to obviously cover up any formations that you want to produce. You've got to have cement there to connect the pipe to the wall. If you shoot a hole somewhere where there's not cement, you'll just get drilling mud or a casing leak or something. But you pump cement down there. You chase it with a wiper rubber that wipes the cement out of the center of the well, and you bring your cement up the outside of the well as high as you need to make your well do what you need it to do. And that's obviously calculated well per well. So at this point, we'll jump over some things here we're going to talk about in later videos. But you'd bring a wireline truck in, you would perforate through the casing, through the cement, into the formation that you want to produce or inject water into. The well will need to be fracked. At that point, you'll probably have to come in here and clean the frack sand out of the bottom of the well. You'll probably swab on it a little bit to clean it up. But at that point, skipping over that, we'll have a completed well bore. At this point now is when we'll run the tubing in the packer. We'll run the tubing in the packer down there, and the tubing in the packer has got to be in an injection well within 100 feet of your top perfs. The top perf on this well is exactly 1,600, and I didn't round that number. It is actually 1,600 feet. And so the bottom of our packer can't be any higher than 1,500. And so we'll run in here and set the packer about 1,550. It's a nice even round number, or wherever it comes out to with the joints. The joints of tubing are all different lengths. You'll calculate, shoot for 1,540 to 1,560, somewhere in there. Now, when you've got the packer down there and the packer seals between the 2-inch tubing and the 4.5, this makes a annulus between these two that is sealed. And what you have to do is you pressure up on this annulus, and you can check to see whether the packer is leaking, whether the casing is leaking, or whether you might have a tubing leak. Now, this kind of test is required depending on stipulations with the well. This well has got all the correct everything. It's got enough surface casing. There's plenty of cement. There's plenty of this. I don't really know all the stipulations. But it passed the engineering department's stipulations to only have to have an H5 done every 5 years. Now, we monitor our annulus pressures, and I do this religiously, and it's why there's gauges on here. You actually, believe it or not, having this gauge here is not legal. I've never been written up for it, but I've been told it more than once. You're supposed to have an open valve, and so the commissioner can come by here and open this valve to see if there's any pressure that's been built up or any suction. Now, this is not what I do, and I don't really care what they say. That's not what's going to happen here. I want a pressure gauge. That pressure gauge is kind of ugly, but I imagine it probably still works. I drive by here pretty much every day, and I can glance at that gauge to see if it reads 0. Now, if we get a tubing leak, which this tubing here is the wear part of this well. This tubing has to be changed periodically. It gets holes in it. It's the, as I say, the wear component of the well. If we get a tubing leak, if it rusts a hole in it somewhere down there at the bottom, it's going to pressure up this annulus between the casing and the tubing. And the pressure on that gauge and the pressure at this gauge will read the same. So if I pull up here, I can see that. And if it's turned to 100 psi, I know there's a problem with this well, and I'll have to work on it. So if it gets a tubing leak, then of course we'll have to get a rig here. We'll tie onto this with a rig. there's a set of slips right in here that's holding the weight of the tubing, plus a stretch of the tubing, plus a stretch on the packer. Pull the slips out of it, go down and unset the packer and pull the tubing out of it. Now, before you can do any of this, you've got to call the Railroad Commission, and you've got to schedule this when you're going to be here. And they often don't show up, but they require you to call in when you do anything with this. I had to take a very important phone call there from a friend that's selling me junk iron. So at that point, we would run the tested tubing or new tubing or whatever tubing you come up with that doesn't have any holes in it, and a Zac Life rebuilt packer down to whatever your packer depth has to be. This well's about 1550. Anytime you work on it and anytime you unset the packer or do any of this stuff, you've got to then perform the H5 mechanical integrity test. And anytime you do the test, it restarts that 5-year clock, and you have to do it every 5 years. And so at that point, we'd come in here and tie pressure and recording device on either side of the head. Pressured up. The pressure's got to be, on this well, it's got to be tested to above 500 psi, and it can lose no pressure over a 30-minute period. It's got to be stable for 30 minutes. And of course, during the test, they'll want this casing observation valve open. I leave all these gauges handy just so that if the commissioner doesn't like a gauge, he can walk up here and unscrew it. But you will, while this is pressured up, you'll want this valve open, making sure there's no pressure on the surface casing, because if you had communication here, that would mean that there was a hole in this in the long string in the 4.5. So back up here at the office, this is the next day. I got to finish up this video. I kind of spent the first half of this talking about what's there, and I'd like to spend the second half talking about how it works. Talk about the kind of the political stigma, I guess, maybe. Injection wells is kind of a buzzword of today, like fracking and then earthquakes, and there's this idea that they can put gas into fresh water. And I know that there are always going to be one-off cases where weird things happen, but I'd like to talk about these and how they are specifically designed to prevent that from being a possibility. All right, we got a quick recap here. We've got a freshwater zone. We've got the bottom of the surface casing, which is covering up the freshwater zone. We've got the bottom of the production casing with the long string, the bottom of the packer, which is on the bottom of the tubing, and we've got the oil sand, or any sand that we want to inject water into. We've got a few perfs there, and as we pump water down the tubing out the bottom of the packer, it comes out the bottom of the packer and goes into the casing and through the perforations into the oil zone. Now this annulus here is annulus between the tubing and the casing. And by pressuring up this annulus, this void here, if we pressure this up and it doesn't leak any, we know for a fact that there's no holes in the tubing, that there's no holes in the casing or the long string, and we know that the packer's holding. And if all three of those situations are true, then we know that the water's not going somewhere we don't want it to. Water's coming down the tubing, out the bottom of the packer. We know for a fact that it's not leaking around the packer. We know for a fact it's not leaking from the tubing into this annulus, and we know that it's not leaking from this annulus out the casing, because we did an H5 test, and if there's no fluid movement anywhere and you've got enough pressure differential between your tubing and your casing while you do it, there's no way fluid is moving any way around inside this casing or through a hole in it. So the next possible place of failure would be this cement. I want to talk about in a second how rare this is, but if somehow you had water migrate through these perfs up through this cement, it would come up and show in your surface casing. So if this fluid comes up anyway, anywhere, it's going to come up into this void. Now this void here does not have cement. This void here is full of drilling mud, and the drilling mud is inert. It stays just exactly like it was put in there. I've plugged wells that were over 100 years old, and the drilling mud that comes out of them looks just like a chocolate milkshake, just like the day they put it in there. It doesn't settle, it doesn't change, it stays exactly the same. But what this does is it conditions this hole so that if you have any kind of fluid migration into this annulus, into either side of this annulus, this fluid will come straight to the surface and you'll sit at this gauge. If you have a worst case scenario, which is exactly what happened in my injection well we're going to talk about next week or whenever I get to it, I had a tubing leak. So we get a tubing leak here, it goes out through here, and fluid is sprayed out in here. And also, probably at the same time, this pressure rise blew a hole in the casing. This is a worst case scenario, both as an operator for the injection well and for, fresh water zone protection. When this happened, we immediately had a spike in pressure. Now the tubing pressure and this annulus pressure is equal because there's a hole in the tubing. Also, as this goes out the casing, there's also a spike in this pressure. So you have this annulus, and the tubing all have exactly the same pressure. It's an instant, as soon as you pull up there, you've had a big major mechanical failure, and at that point it's got to be fixed, but that's for another video. But I just wanted to show how that there's really no way water can migrate from here into a freshwater zone without going through 3 different layers, and each layer has got a tattletale on it. It'll be obvious. And what you hope for is that you would catch this, this leak here on a H5 test before you would get a tubing leak, and that's generally what would happen. But these both happened, probably exactly the same time. I want to show you a well log real quick and give you kind of a real life understanding of where you would deal with small amounts of cement and how that they do hold water back, and they're actually quite, they work quite well. So this is a real good representation of a normal well log of most of the stuff that I produce, most of the stuff that I own. In this little bitty zone here, this upper zone, it's called a gun sight. This upper gun sight is where most of the oil I produce comes from. This little bitty 2, 4, 6 foot thick little bitty deal. Doesn't look like much, but there's been a bunch of oil come out of there. There's 2 lines here we need to worry about. This one is a spontaneous potential. It's a galvanic reaction between the rock and the drilling fluid, and this dashed line is the deep resistance of the formation. This is telling us if it's a highly conductive or a non-conductive fluid. So if we lay a ruler up here, there's 2 rock layers we're dealing with. It's either shale or sand, and anything that touches this ruler here is going to be shale. So this is shale, and I have a feeling that this is supposed to be shale as too. This is where they started the log, and they didn't have, sometimes it takes a few feet for this stuff to sort of start working. So we've got shale, probably a little piece of shale here, shale. If we go to the other side, it's the same deal. We've got a big giant water sand up here. Now here's the sand, here's the sand, here's the sand. So we've got an oil sand here. This is showing high resistive, and this is not a geologist. This is just what the guy logging the well thought probably. This is probably oil. This is probably water. This has got a really high resistivity, means it's probably gas, and it turns to water. And there's also a little bump here. It's quite possibly a little oil right here that turns to water. Now, there's only, this is 1,500, 1,550, 1,600 feet. There's only 2, 4, 6, 8, 10, 12, 14, 16, 18 feet between the top of this and the bottom of this. If you shoot the water, if we were to perforate into this or perforate into the bottom, you get the ocean, and you've got to be really careful. You want just to get into the oil. You want just to get in the top of it. Looking at this, if we got into this, it was pretty tight and fracked it, I wouldn't be scared to go to several thousand PSI, 2,500 pounds or something, out the casing into this formation, and I would not worry, even at this small footage, at a few thousand PSI, about this migrating up through the case, up through the cement, and getting into the bottom of this. You frack this, and communication does happen in small little situations like this. But even at 18 feet, I would feel confident putting at least 2,000, 2,500 psi a frac job on this sand, and not worry about it traveling up through the shale and getting into here. That small amount of cement will actually hold back that much pressure. Okay, so a bunch of key takeaways. I want to see if I can get all this in one shot here. I'm sure I probably will screw it up at some point. If you're the average person, you got an injection well in your backyard, don't be scared of it. It's not going to cause you any trouble. They are designed in a way you're not going to have water come back up into freshwater zone. You're not going to have it's just not going to be an issue. If your operator takes care of stuff, it will not be a problem. There's a lot of, as I said to begin with, sort of political stigma about injection wells, that they're a bad thing, that they're something to do with fracking. People don't really understand what they're for. So a lot of people think fracking is a new thing. Nearly all oil wells ever have been fracked, probably at least 95% of them. In the old days it was done with explosives, nowadays it's done hydraulically. And somehow there's this fracking fluid that you've got to put in these injection wells, and the injection wells are causing earthquakes. And I think that all that is just absolutely ridiculous. I wanted to show you the log because to give you an idea that it doesn't require much cement to seal that pipe. The cement bonds chemically both to the rock and to the casing. It doesn't take much cement to seal something like that off, and injection wells have got to have a number of 100 feet of cement above your top perfs and above your packer. I think it might be 450 feet, but don't quote me on that. And also wanted to show you because it's obvious oil floats, and we've got all these different little zones here. There's 3 of them in that log, and the oil floats. And if there was any communication between these different zones, the oil would simply communicate up to the highest zone, and that doesn't happen. And there's several situations I can show you where you've got an injection well that injects water into the lower zone, and you've got a well somewhere that is in the lower zone, and those 2 wells communicate. If you put a bunch of water in the injection well, the producer begins to make more water. And the same way with the upper zones. There's a lot of water moved around in both these zones, and they absolutely do not communicate. Even a lot of these wells, this has got 18 feet of shale between the 2 zones. A lot of times they're less than that, sometimes it's more. But there's areas that have only a few feet of shale, and still that water pressure from the upper or the lower zone do not communicate to the other zone. They stay in their layers. They stay in their sand. And there's this. I've read a lot of people talking about on the internet. A lot of typically environmentalist liberals. They're talking about these injection wells, how they cause earthquakes, and there's thousands of barrels of water put in this injection well, like it's a huge number. I've got many injection wells that are permitted to 500 barrels per day. We move thousands and thousands of barrels of water per day in all my stuff in this several mile area, and nothing surfaces, nothing comes to the surface. There's never once ever been an issue anywhere. And over the last 100 years, but even just in the time that my family's owned it, the last 50 or 60 years, there has been a 50 years times 1,000 barrels a day or 2,000 barrels a day, astronomical amount of water moved out there. And if you frack a well, frack one of those gas wells that they're fracking so hard, the shale, and you bring back a few thousand barrels of that water and put it in an injection well, it's a drop in the bucket to just what I personally move daily in these shallow well zones. But anyway, they talk about this idea that the water's going to migrate through the formations to get to deeper formations and cause earthquakes. And they're saying that because the earthquakes we had around here, they measured, are much deeper than any of the fracking or any of the injection wells that are being used. And that's just a way they came up with something to say. I think it's just a lie about how they're causing those earthquakes. I don't believe it. Generally injection wells, the deeper the well gets, the tighter the formations, the more pressure the formations are under, and therefore the more pressure you've got to put at the surface to get the water to go into the sand. So anyway, I just wanted to kind of talk about injection wells. If you got one in your backyard, don't worry about them. They're not an environmental hazard unless you have a leak at the surface can be a problem. But if you got a good operator and keeps good equipment, that's not an issue. They are. I wanted to show that it doesn't take a lot of cement to seal between the rock and the casing. 10 or 15 feet is good for a few thousand psi, especially for a short-term situation. And I want to talk about how that you can have a couple of different formations that run very close together on top of each other that are miles and miles long. And in my experience, I've never once ever seen communication between 2 unrelated zones. If there's a rock layer between them, they're sealed off. It does not permeate up. It does not permeate down. It stays exactly in the formation where you put it. I've never once ever seen a migration between zones, ever. So appreciate you watching. I actually H5 this well yesterday, and get that video put together. I'll have it out tomorrow or maybe late tonight. I ought to say too, I call them H5s, and where that term comes from. In the commission, all the paperwork that has to do with an injection well starts with an H, and it's just H-5 is the piece of paper you had to fill out with all the information of your test, and so they're just known as H5s. Anyway, I got a rig video put together. I may try to have it out. I've been doing a little bit of work on the rig. SCADA system is coming soon. I got 3 more videos I'm working on. I'll have those in a week or 2. I got a lot of stuff going. It's finally cooled off. It's nice weather to work. I can work and not die of a heat stroke, and get some stuff done. Appreciate you watching. Like, share, subscribe. Catch you on the next one.